Hello, I'm Yogananda Jeppu. I'm a fellow at Honeywell, and I'm going to be talking about arguing about safety, our simulations and formal method, the keys. It is a thought paper which I would like to present. There are no results in this, it is just my ideas on what perhaps could be a way of looking at safety. I have a background in safety in the sense that I have worked on the various flight control systems which are very safety critical. And currently, I'm working on formal methods and model based systems engineering. So, safety is a key there, and I have been using formal methods and model based development techniques to come up with safety cases. I'm also an adjunct faculty at NIT Surathkal and MIT Manipal. With this brief introduction, I would like to say that safety is a perception. And you can see that the way people look at safety, it is in their mind. So each one has his way of thinking about safety. So you see those, they're kind of funny if you look at it, but then this is the whole key to the talk that I'm saying. So everything is in the mind, and safety is a perception. So what do we do about it? Okay. So what we can do is we can start defining with this what is safety, and I would like to use this term taken from this paper, Peace of Mind, an experiential safety framework for automated driving technologies. So it is an IEEE paper, I think. The DOI is given there. What it talks about is an experiential safety is the state. It is always the state in which all doubts and concerns surrounding a person's emotional well being, his physical health, his motivation, fulfillment, and social well being are greatly reduced or eliminated altogether. It is basically peace of mind. And this paper has some very interesting, dialogues like this. They did a survey, and how do we see, how do people or the drivers see safety? Okay, so one person is saying, if I have any passengers, I take care of my passengers. I wouldn't take risk with my kids in the car like I do when I am alone. So there is a whole change that is happening there when we look at safety of an individual or with the safety of the family. If some people go too slow, they cause other people to become agitated and do crazy things. So a safe driver is someone who follows what the other traffic is doing. Okay, so safety we will have to look at with all these things. So it's a very nice paper to go through, and I will not dwell too much on this, but this is enhancing my take that safety is a perception. So now let us look at the aerospace safety process. So we have the aircraft requirements, we have system requirements, and then we have the item requirements and the design that takes place. And then we take to the right side where we have the system verification and the aircraft verification that happens. And if you look at the chart, you will see that as we go down the V model, it is all about safety. So we are doing an aircraft level FHA, we are doing the preliminary safety analysis, and then we do a system level FHA and the preliminary safety analysis, and it goes on. And having done that on the left side, we go to the right side where we validate those things. So we validate the system FTA, we look at the FMEA, then we look at the aircraft level CCAs, and we finally do a system analysis at the aircraft level and a safety analysis at the aircraft level to ensure that we have a safe aircraft to fly. So this is our ARP process. People with an aerospace background would be, aware of this. But what are we doing here in this? Okay, so what we are following is perhaps a traditional safety analysis process, I would say, where the FHA, FTA, and all that, this has been there with us for years together. And what they say is we actually follow a Swiss cheese model of saying that circumstances they align, and having these different circumstances align in a manner that the hazard leads to an accident. Okay, so it is like a child going with the mother, and the child sees an ice cream cart, and then the mother has got a phone call, and then there is a car on the road, and the driver spills his coffee at that instant, and the child crosses the road to go to the other side, and then the accident happens. So these are the different circumstances that happen, and because they lined up together, there was an accident. Okay, now these are all based on the analysis that we do is again based on the human minds and our intellect. And then we say that we actually brainstorm these things. We get into a room and we discuss this. So collective experiences and these failures, the analysis that we do is a collective, decision process, I would say. Now, I have highlighted these human minds, and collectively, we will see this in more details how they, affect us. So there is one more technique. I think there are papers on this in the ESS this time, which is called as STPA, or System Theoretic Process Analysis. So engineers are using this. I have used it personally, and it's an excellent way of looking at safety. I have been teaching these techniques at the universities, and students like it very much. It's very easy for them to understand, and of course it is a something that the professionals can also do. It is not at a, a student level. So we can do a lot of good things in this, but these go hand in hand with the traditional processes, so to say, that we have. In this case, what we do is we look at a system as a control system, I would say. So there is a controller, there is a control action that happens, and there is a controlled process which gives a feedback. And then the accidents happen because the control actions are not done properly, and they could be because different reasons. So that is the basic theory in this. So I will not go deep into it. But then the analysis that happens is again collective discussions and brainstorming with a group of people together. So then what is the problem with all this? The problem is the barriers to collective decision making. Okay, so there is a phenomena called groupthink. So you can look it up in the wiki, which is a psychological phenomena that occurs within a group of people in which the desire for harmony or conformity in the group results in an irrational or dysfunctional decision making outcome. So there is a problem with 10 people sitting together and making decisions together. Okay. So the cohesiveness or the desire for cohesiveness in a group may produce a tendency among its members to agree at all costs. And this can happen, and I have seen this happen. If there is a senior person there, and if he is making some decision, everything aligns to what he says, okay, or he or she says. So this is what happens in a group. Okay, so we think that we can get into a group and have some beautiful discussions, and very critical things could happen. We will discuss on what things will fail, but what we end up is we'll say, okay, there could be attrition, people will be leaving, software is going to fail, this hardware equipment will not come. So these are all pretty standard things that are our risks. Okay, we are not coming up with any new risks that needs to be discussed. So this is one of the drawbacks of coming up with a collective decision making. Okay, so the group thing, there are certain symptoms they exhibit. So what happens during group thing is that we have an illusion that we are not vulnerable. Okay, there is a lot of optimism. There is a God feeling that you know that there is a unquestioned belief that we cannot fail. Okay, so we are the designers of the system, and we have never failed. We make very good systems. We have done all the due diligence. Okay, rationalizing warnings that might challenge the group's assumption. Okay, I asked the experts, and he says it cannot happen. Okay, and all these things I have felt it myself. I will come to that later. Okay, these are the dialogues that were told to me. So, but very interesting that when I started reading on this, I could correlate with what had happened, and it was what happened to me was a group thing, and stereotyping those who are opposed to the group as weak, evil, or biased, and all that. Okay, so I have been told you test too much yoga. So because you are testing too much, you are finding these issues, you should not test this much. Okay, you are going all over the place. These things will not happen. Self censorship of ideas that deviate from the apparent. So there are people who are observing the other group, and they will not, speak up at all. They will keep quiet, and then maybe outside the room they will say, Yoga, I think you were right, but yeah, I mean, but they don't speak up in the room. Okay, so these discussions don't happen the way it should be happening. So that is my, I would like to submit that these decision processes that we have don't happen the way it is supposed to happen. Okay, and then illusion of unanimity. Okay, among the group members, and I have heard of this. So I take it that the silence is that we accept it. Okay, I see it every day in my telephone calls. Nobody talks these days. In the pandemic, everybody's on headphones and nobody talks. And then we say that, okay, if you're not talking, that means you have accepted what I have said. So this is the thing that is happening today. Okay, so this is about our group discussions and all that. What about the failures themselves? So this is a very interesting paper on common barriers to reporting medical errors. It is in the medical domain, but then you have all the psychologists also there in the medical domain, so they can discuss among themselves. So they come up with very nice papers. So I just was going through this, and I found a book also which had examples of the medical domain. And we don't see people, at least in the medical domain, talking about failures. Okay, so why is that? Why people don't report failures? Okay, so some of the things that are is a fear of the consequences. Okay, that if you report a medical error, maybe that something bad could happen to you. You may lose your job. So there is a fear that is there. There is a lack of feedback, both lack of feedback by the administration or a negative feedback that is coming out. Okay, and if that negative feedback comes in, then they see that people stop reporting errors. The same thing happens in aerospace. Very rarely people admit errors. Okay, companies will never admit errors. Okay, I admit errors all over the place. If you look at some of my slides and some of my discussions that I've had and some of the videos that I have taken, it's all about failures. I talk about failures, and I keep telling the youngsters that I'm going to talk about the failures I have encountered. You make new failures. Don't make the same failures I have made. But do everybody do this sort of a thing? I think nobody does that. Okay, so there is a fear of admitting failures. There is a problem with a group collective discussion. And then there are unconscious biases that we have as human beings. Okay, so one thing is this cognitive dissonance. Okay, cognitive dissonance, which describes that when we avoid having conflicting beliefs and attitudes because it makes us feel uncomfortable. Okay, I believe in something, and then somebody tells me that that belief is wrong. Then I will come up with an idea. Maybe perhaps he doesn't know what he's talking about. This happens in political rallies. So we have people who are very you know attached to certain political entities, and then everything that is done by the group or that party is supposed to be right. And then they have this unconscious bias that they tell others that no, what you are doing is wrong, because this party, I belong to this party, and that is right. Same thing happens to in the aerospace. So I am a VNB person, I am a system designer, I am a software expert. They are the parties, and each one has his thought processes which they guard, and that is a silo that is created. And then we have our own beliefs, and we don't budge from those beliefs. So that is also an unconscious bias that can affect your decision making. And there is one more thing called survivorship bias, or a survival bias, which looks at something has already passed. Okay, we don't look at the failures, right? I have cleared the pandemic. I am alive, right? I left behind a few people, but I am alive. So I look forward. I don't look at the mistakes that happened earlier that caused the pandemic. So I won't wear a mask. Okay, sorry, I'm not doing it now, but nobody's in the room. But then that is the way it is. So not wearing a mask could have perhaps caused this spread, and people would have lost their life because of this, right? But then I am not looking at it anymore because I have survived it through. Okay? So this is what happens, right? And very interestingly, there is an example of the NASA space shuttle, so you can look at this reference where the managers refuse to look at this. There was an issue, and it was found during testing, and they did during the flight also they found such issues, and they never went around. They didn't do a walkthrough on the space shuttle to check if there was a damage. And during re-entry, there was an explosion. We lost the whole space shuttle. Okay, with the crew and all that, right? So this is the most dangerous situation where the managers, they ignore or discount the risk and get into a wait and see attitude. Okay, and this could lead to catastrophic failures. So it is all about minds, and safety is about people and their minds. So some of my experiences I would like to recount here is in one of the programs I did a lot of random simulations, and I found out that there was this small control element block which had a problem. The algorithm, there was something wrong with the algorithm there, and it was okay, but the way we were using it was slightly different, and maybe it was not meant to be used like that. Okay, now, this one, I didn't actually test it on a complete aircraft model. Even though I had the model with me, I did not know how to test it. Okay. So, I mean, that is the way it was. I was evolving. And today, if you let me, I have that experience and I can really test it perhaps. But I didn't do the testing. Okay. And what happened, right? All these biases were, put on me, right? So you are testing too much, you are doing random tests, who told you to test, and you are coming out these errors. The experts have said nothing like this can happen. And then when the aircraft was landing, it landed and then it wanted to take off, and then the pilot had to push the stick down and to abort that movement of takeoff. There were certain more errors, and then I had to go ahead and change it. Okay, so that is a failure that happened, and all those unconscious biases, they come out during the meetings. Okay, and I also kept quiet. So that is an unconscious bias on my part also, which is coming on as an experience to me. But the lessons learned for me was that simulations are very, very good, especially the random simulations. Okay, another experience was kind of recent, where because now I am an experienced person, I did a lot of random simulations and I didn't find any issues. The hardware was working perfectly fine. And then we had a flight test. And during flight test, during landing, the system failed. Okay, period. Okay, what happened? We analyzed it, we knew what the failure was, we rectified it. Okay, then when I got some breathing space, a lot of people, the management is looking down your neck, breathing down your neck, and pushing you. So when all that got over and we had a successful flight test, I did a simple formal methods run. Formal methods is a mathematical technique to prove your system right. Okay, so I did that, and I said that okay, this failure that happened in air will never happen. And the formal methods came up with a counter example which exactly showed the case what happened in air. Okay, so simulations happened here, but they are not sufficient. They could not bring out this case for me. Okay, and this is another experience. I have the article on LinkedIn. You can have a look at that. An error was found after 12 years of successful flight. Okay, 12 years of successfully flying the aircraft, and then we find an error. And then I again used formal methods, and then within 1.4 seconds, it came up with the exact situation that happened in air and told me that the algorithm was wrong. Okay, so this is the power of formal methods. So I am now coming to what we need to do perhaps. Okay, so this is our development process. Okay, we all know this, and I start with the mental models here. So system that I am trying to make, I have it in my mind. It is in the mind of some two, three people, right? We have discussed it. So in our mind, we know what the system should be like. So that is a mental model. From the mental model, we create requirements. And the requirements could be model based, they could be, text based or something. That is a set of requirements which are defining this mental model. And from that, we make more models, we make the design models, and then we make the code, and then we do a lot of testing. Okay, so this is the development process that is being followed. Okay, nothing wrong in this. We have done very well here, but there could be some issues. Okay, testing is excellent. I am not belittling the fact that we should not test. Okay, testing is a must. It is going to remain for a long time. Okay, what is testing bringing out? Testing is bringing out the fact that my lowest level models and my code is same. They are perfectly matching. They are behaving in the same manner, and that is what you see is the tick mark in the interfaces there. Okay, the question mark on the interfaces are the correctness. Is my model reflecting my requirements? Is my code reflecting my requirements? Is a question mark. Okay, we can do maybe 80% of the time, but 70% of the time we find errors in our requirements. Okay, that is a known published fact. Okay, now that is something, on our process. But what about my mental model? Okay, is my mental model completely captured in my requirements, the completeness aspect of it? Is it done? Okay, so when I look at this is maybe functional requirements, but now I look at it as safety requirements. My mental model of the safety, which has come out through all these you know processes of collectively deciding what needs to be done with all the biases, I have taken it forward. Okay, so my mental models are also biased. Out of that, I have created requirements which are my safety constraints. And then we have issues. I don't know whether I have captured everything correctly. The completeness aspect is not known, and the correctness aspect is not known. Okay, so what should be the solution? The solution could be to either remove the people, not possible at all, or perhaps give them something more to think about, something objectively to think about. And this is some paper which I am very familiar with, not my paper. So I'm very familiar with the this particular aspect. So I thought that this could be perhaps a way forward. Okay. Now, what is this? This is about having my system, that is the tracing, the setup that is there. That is my test setup. So I have a model, and I may have a code or something. I may have an actual system, and I do lot of testing. And what happens out of these testing is I get a set of input profiles and I get a set of output profiles, and that is my trace set that I have created. These could be on an automotive domain, on an aircraft domain, medical domain. These could be field trials. These could be simulations. It doesn't matter what it is. It is basically a set of inputs and the outputs. Okay, having done that, we give it to a model learning process. Okay, the model learning process goes through these traces and comes up with a mathematical model. Okay, the learned system model, which is an output of the model learning process. Now the system behavior is kind of abstracted out into this mathematical model. Okay, so this is my reverse engineering of my actual traces. Okay, and having learned this model, what do? I reverse engineer the conditions out of it. Okay, basically I am going back and trying to see what my mental model could be from this particular development. Okay, so I am trying to come up with these conditions, and then I use formal methods. Okay, I prove that nothing bad can happen with this. And so as I, extract these conditions, I will check whether this condition is valid, which is inferred from my model. Okay, if it is not valid, what comes out is a falsification, and what comes out is a counter example which tells me that okay, this model is there, but in this situation, this condition is invalid. So even though I have learned that this condition is the behavior, it becomes invalid because of certain inputs and outputs. And though they go back to my trace set as additional input sets. Okay, and then I may have to redo the model. So when I do all these iterations, what comes out is a set of counter example where things are failing, and then a behavioral aspect that is my, a reverse engineered, perhaps I would say within codes, a mental model. Okay, so does that behave the way I want? Maybe I can convert it into a set of requirements automatically, and then look at those requirements to the exact requirements in which I started. I have done this, not this whole process, but at least the generation of requirements and converting them into text so that I can read it and tick off. So I used to go in the bus, going back from office. I used to get 1 hour in the Bangalore traffic. So that 1 hour I used to spend, reading the 500 or 600 requirements automatically generated. Okay, this is doable, and what it brings out is a set of requirements which is the behavior, actual behavior of my system. Okay, and then you look at your mental model, look at this. Okay, oh boy, this is not what I wanted. This is a failure case for me, right? And then you go back to the drawing board, argue on these failure cases, improve your safety, and perhaps with all these feedback coming between your simulations, your formal methods, and your collective human processes and human minds, maybe you will have a better system to look at. So in conclusion, I would say that human minds are defining perceived safety by other human minds today. Okay, and we are using different techniques for that. So this is what is happening today. There is a fundamental flaw in this regards to one man's meat is another man's poison. Okay, what we perceive may not be what is perceived by the person who is going to be using your system perhaps. Okay, and then we have all these unconscious biases that prevent human minds to produce all the failure situations. Okay. So, what I would like to submit to the audience is that simulations and formal methods feeding each other, okay, there should be a feedback loop, is perhaps an interesting proposition for ensuring safety in systems. Thank you. Every accident, this is a very nice quote, every failure is a notice that something is wrong with the system. Men, methods, material, something is wrong with all these. So, what you need to do is you need to go investigate. You need to accept that there is a failure. Maybe you have to accept that you have created that failure, then act on it to rectify it. After having done all that, you need to remember it. Remember that failure, maybe report it. And then you need to teach this to the next generations or other people so that they don't make the same mistakes again. Thank you very much for listening in.